Hi dear student, this is Sanal from Gilbodi classes. Welcome back to AS level CAE 9702 physics series. This is module 2 kinematics part 4B of the series. In part 4A, we have discussed the theory part of equations of motion. In this video, we are going to practice some questions where we can discuss more theory, more concept about the equation, how to apply this equation, how to select the equation for a particular question. All these things we will check in this session. So in this session, I have selected some good question where you can think and apply the knowledge you have gained about equations of motion. So when I give you the questions, you pause the video and try to do it by yourself. And after that, you can watch the solution and you understand where you got stuck in that question, where you have made the mistakes. Understand your mistakes and don't repeat it in the next questions. Let's start the session. The first question. So this is the first question. You can pause the video and try to do it by yourself. Okay, let's read the question. A police car starts from rest and accelerates uniformly at 2 meters per second along a straight road. At the same instant, a thief passes the police car moving with a constant speed of 20 meters per second. Okay. The first part is you need to write an expression for the displacement of the police car and the thief after time t. So that means this is when you check this question, one is motion with a constant acceleration, one is a uniform motion, right? There is no acceleration, it is a constant speed means what? The acceleration is not there, acceleration is 0. So you need to find out the displacement for what? The police car and the thief after time t. So the first question, displacement is the requirement. Okay, you need to write the displacement expression for the police car and the thief after t time. Okay, you need to write an expression in terms of t. First motion of police car, when you check, if it is uniformly accelerated motion, you can use the equations of motion. Here, what is the requirement? Displacement. So you know that you remember the equations. V is equal to u plus at, first equation. S is equal to ut plus half at square, second equation. V square minus u square is equal to 2as. These three equations you know. Out of that, displacement and time, I told you, time is the requirement or time is the, I told you in the theoretical explanation, if time is given or time is present in the question, so only two equations are possible. What are the first and second, right? So out of the displacement is required, what is the second equation? So S is equal to ut plus half at square. This equation you can use. First equation, displacement is not there, right? So this is how you analyze which equation is suitable for the question. You need to think about three equations. If time is there, first two. If time is not there, only one equation, v square is equal to u square plus 2as. Right? So we will use this equation. In this condition, it is given starts from rest. That means u equal to 0. And accelerate uniformly. Acceleration is given 2 meters per second square. Right? So you can substitute these values in the equation. So displacement for the police car, I'm writing it as SP. So ut 0 plus half into a 2 into t square. So SP is equal to t square. So this is the expression for the displacement for the police car, right? At any time, if you substitute the time, you will get the displacement. Clear? Then, next you need to find out the expression for motion of thief, right? So motion of thief, when you consider it is at constant speed means acceleration is not there. If acceleration is not there, you have only one equation, velocity is equal to displacement upon time. So from here, you need the expression for displacement. So displacement of thief equal to velocity into time. Here speed is given, which is 20 into time. So st is equal to 20 multiplied by time, that is 20t. So you got the expression for both now. That is the first part of the question. I hope you got it right. Now, second part, B. Calculate the time at which the police car catches the thief. When police car catches the thief means what? The displacement of the car and the thief is same, right? You can equate this one. So t square equal to 20t. How you are writing it? So when they are catching, okay, look at this one. This is police car and this is thief moving at constant speed. After some time, what happened? They both will reach the same position. At this point, what happened? The displacement of police will be equal to the displacement of the thief. Okay, this concept you will use here because they have mentioned that calculate the time at which the police car catches the thief. Catching means both will have the same displacement. So you can equate the displacement equation. So t is equal to what? 1t you can cancel. It will be 20 seconds. I hope you got this answer too. Okay. Next, third. Explain why two equations of motions are required to solve this problem. Because two motions are different motion. One is with a constant acceleration, one is with a zero acceleration, right? One motion is with a constant acceleration. What is that motion of police car? And one motion is with a zero acceleration. That is motion of thief. Correct? So that's why you require two equations. Understood? I hope this question is clear to you. So you identified which equation is required for the current question by the method I have explained in the theory class. Second one, what concept we have used, that one sentence, what is that? The police car catches the thief. At that point, you will identify the displacements are same, both are same. That means you can equate the equations for displacement and you can find out the time. Okay. Then one theoretical question, why do you require two equations? Because one motion is uniform acceleration motion, one is zero acceleration motion. Zero acceleration means what? Constant speed or constant velocity motion. Okay, clear? I hope this concept is clear to you. We will move on to the next question. Okay, this is the second question. Pause the video and try to do it by yourself. Okay, let's understand this question first. A particle is moving along a straight line. So a particle is moving along a straight line. Its velocity is 10 meter per second at a point. You consider this is the point A. At this point, the particle has a velocity plus 10 meter per second, right? So at this point, what is this? In this, you can take it as initial velocity u. And it undergoes a constant acceleration of -4. Constant acceleration minus means it's deceleration, right? So you can say an acceleration is there for this object, which is -4 meter per second square. This is a constant acceleration. And it reaches a point B. So this is the point B. At this point, its velocity is given. So you can say this is the final velocity. V is equal to -6 meter per second. Okay. So -6 meter per second. So what is the first question? Calculate the time taken to move it from A to B. So what is the time taken? So first you need to find out the time taken. So what is the procedure? First you will identify which equation is suitable for this question. So time, I told you if time is required, only two possibilities, one or two. First equation or second equation, right? So what is the requirement is time taken from A to B. So we are selecting one equation from first and second. Next step, you will check what is given here. You have the velocities. Displacement is not there. So velocities are there, means first equation you can use, right? V equal to U plus AT. So you identify the equation required to solve this question. So you have all the values. Check this one. V is what? -6, which is equal to U 10 plus A is equal to -4 into T. And it will be, what is t? Solve this equation. Minus 16 is equal to minus 4 into t. Minus minus will become plus. T is equal to 16 by 4, which is equal to 4 seconds. You got the answer. So simple. The only thing is you need to identify the right, choose the right equation. For that, it's the easiest method, okay? So you can follow this. Next question we can check. B. Find the displacement between A and B. So look at this one, between these 2 points, displacement you required. Now, T is already there, displacement you can use first equation. And initial and final velocity is there. You can use what? The third equation also. So we will use the second equation first. S is equal to ut plus half at square. Initial velocity 10 into 4 plus half into acceleration minus 4 into t square 60, right? You solve this one. 40 minus 32, which is equal to 8 meters. So simple. You got the second answer also. So we will check whether you can use the third part also, third equation. So you can check that whether we can use the third equation also possible, right? So you check with the third equation, v square is equal to u square plus 2as, right? This is the equation. You have the values for v, final v is what? Minus 6 the whole square equal to 10 square 2 into plus 2 into a is minus 4 into s. You solve for s from this equation. So 100 minus 100, 36, right? Minus 36 minus 100 equal to minus 8s. So 64 equal to minus 8s. S is equal to what? 64 by 8, which is equal to 8 meters. You're getting the same answer, right? So this is how you need to solve equations of the questions from equations of motion, right? Once again, I will tell you the procedure, the step by step. If you remember, you apply the same step for whatever question you are getting, you can solve it. First one, read the question properly, analyze the question, check. First thing you need to check whether time is there in the question or not. Time is there as a requirement or given. Then only two equation. What is that? First and second. Third equation doesn't have the term time. So then you check whether velocity is required or displacement is required. If time and displacement is there, second equation. If time and velocity is there, first equation you need to use. When you substitute, use it substitute with the proper sign. Okay, that is the only area you can make a mistake. With the proper sign, if you substitute and find the missing value, finish. If time is not there, only one equation. V square minus u square is equal to 2s. Finished. It is so simple. The third one. Explain the physical meaning of the negative velocity. Okay. What is this negative velocity? The negative velocity means the direction is opposite. The direction has reversed. It doesn't mean that there is no acceleration or the velocity is zero, nothing. That velocity negative sign means the direction has reversed. Got it? So see the physical meaning of negative velocity. Is simply the reversal of direction of motion. Okay. So we finished the second part. I hope you got this right. So my objective is to give you the idea of how to solve the equations of motion question. The procedure, the steps to analyze and solve equations of motion question. Okay. Next one, third question. Pause the video and try to do it by yourself. A particle moves with uniform acceleration. It travels 30 meters in first 4 seconds and 70 in the next 4 seconds. Okay. So you need to show that the acceleration is constant. Calculate the acceleration, determine the initial velocity of the particle. Okay, pause the video and do it. Okay, now I'm going to solve this. So you need to show that the constant acceleration means what? The displacement, okay, displacement will increase constantly after equal interval of time. If you're connecting it with displacement, for example, acceleration is constant means you know that the velocity is changing uniformly, right? If you want to connect it with the displacement at equal interval of time, equal increase is there. And you need to understand one thing, the displacement, you may make a common mistake. When I give the solution, you check that whether you made a mistake or not. So this has two parts, right? 30 meters in first 4 seconds, 70 meters in the next 4 seconds. So you can understand it clearly. A particle is moves with a uniform acceleration. Okay, that is mentioned in the question. 30 meter. So if when t is equal to 4 seconds, the displacement is 30 meter. Then next 4 seconds, the displacement has 70 meter. Now you need to check that. Which equation you can use? Displacement and the time, right? Displacement and time is given. So acceleration is constant means we can check that. First motion you will check, okay? S is equal to ut plus half at square, right? Ut plus half at square. If this follows this motion follows this equation means acceleration is constant only, right? You can prove that one. S is equal to, they didn't mention that it has starting from rest, so they may have an initial velocity. So you take that there is an initial velocity u into first situation. What is that? 4 seconds plus half into a constant acceleration. Acceleration what value is not there, so you will put it as a, and into t square. Okay, look at this. T square is what? 4 square. So if 4 is the time, the displacement it's 30 meters. Okay, that you can substitute here. So 30 meter is equal to 4u plus 16, so 8a. So you got this equation as your for the first time duration, right? 4 seconds. So understand this question carefully. Second situation, next to 4 seconds, okay? Next to 4 seconds, you don't take the time as 4 seconds. The time will be 4 plus 4, 8 seconds, okay? So t total time will be 8 seconds. And the displacement, don't take that, the displacement is 70 here. Already, first to 4 seconds, what is the displacement? 30 meter is covered. Next is 70, right? So you can say that this will be 100. The displacement is 100 and the initial velocity u, time is 8 plus half a 8 square. Got it? You understood? So how the displacement has become, because it is continuous motion, right? The time first to 4, next to 4, if you are considering total time will become 8. Understood? Total displacement first to 4 second 30, next is 70. Total is 100. Understood? So you can solve this one. 108 so 100 is equal to 8u plus 64 32, right? 32a. So these two equations are compatible, right? You can solve simultaneously means it is satisfying the equations of motion, so the acceleration is uniform. Understood? So you have two equations now. So how can you prove that? Since the displacement is increasing uniformly in equal interval of time, acceleration is constant. Okay. So first part is done. Second, calculate the acceleration. So acceleration, how can you calculate? You can solve simultaneously this equation, two equation. 30 equal to 4u plus 8a. 100 equals 8u plus 32a. Right? You know how to solve this equation, right? Solve this equation and find out the value for acceleration first. Acceleration means you need to eliminate u from this equation. To eliminate u, if you multiply the first equation with the -2, what happens? U will become -8. When you add, it will get cancelled, right? So this equation will become 60 equal to 8u. 60 equal to 8u plus 16a. 100 equal to, you need to, minus 60 is equal to minus 8u minus 16a. 100 plus 8u, 100 is equal to 8u plus 32a. So when you add, 40 equals, this will get cancelled, and 16a. So a is equal to 40 divided by 16, 2.5, right? 40 divided by 16, 2.5. Acceleration is 2.5 meter per second square. This is the answer. Understood? Now, next part is determine the initial velocity of the particle. Initial velocity means you need to find out. So you can use any one of this equation and find out. So I will use first equation. 30 equals 4u equals 8 into 2.5, right? So 4u equals 30 minus 8 into 2.5. So it will be 8 into 2.5, 4, 10, 20. So it will be 10 is equal to 4u, u is equal to 10 by 4, which is equal to 2.4. What is that? Meter per second. Understood? I hope you got these answers. So we will move on to the next question. Question number 4. So now I have taken the motion under gravity. Okay. So motion under gravity, you can use the equations of motion. Why? The acceleration due to gravity near the surface of Earth is constant value 9.81, right? So read this question and do A, B, C, D part, and then you check the answers. Okay. Now I am going to solve this. A stone A is dropped from the top of a tall tower of height 80 meters. At the same instant, another stone B is projected vertically upwards from the ground with a speed of 20 meters. Speed of 20 meters per second. Both stones are moving in the same vertical line. Take the acceleration due to gravity as, okay, you can take the acceleration due to gravity as 10 meters per second. See, this is the situation. You consider a tower, a tall tower. Okay. A tall tower. A tall tower and a stone A. So you are dropping. This is A. A stone is dropped A in this direction. At the same time, so that means at the same intensity, the same time you are throwing another stone B in the upward direction. Both are in same line. Okay. This is the condition. And they have given that it is thrown upward with 20 meter per second. So here initial velocity is 20 meter per second. So this is given. These are the only data given. So acceleration, you know that it's 9.81. You can take it as 10 for this question. Write an equation for the displacement of stone A from the top of the tower after t time. So that means after t time, where will be the position of the object? Okay, so you know that when you drop something freely, you're not throwing it. Okay, if they are asking you to throw, initial velocity will be there. Throw the stone downward with an initial velocity. If you're dropping something, initial velocity will be zero. U equal to zero. Okay, and acceleration is minus g. Acceleration, I'm taking downward direction as negative, so I'm taking acceleration is downward negative. Okay, so acceleration is minus 10 meter per second square. So you need to write, look at this one, you need to write an equation for the displacement now. Displacement and time is related. Which equation? Time is there means two equation, displacement relation means second equation, right? So you got the equation S is equal to ut plus half at square. So this is the second equation. So displacement, you need required displacement of stone A. So I will write it as S of A equal to initial velocity 0, so ut will become 0, plus half A. Look at this one, A is minus 10 meters per second into t square. Got it? Now this will become, look at this, this is the displacement, right? Displacement of A. In which direction it is happening? Displacement is happening downward. You have taken that as negative. So this displacement will also be negative. Minus SA equal to minus 5t square. So S displacement of stone A at any time will be equal to 5 times t square. So this is the expression. Got it? This is the equation. This is the first part. Now B. Write an equation for the displacement of stone B from the ground after t time. After t time, what will be the displacement? So you can say that displacement of B. So when you check this one, displacement of B here, S is happening in positive direction. So S of A will be positive, right? Upward you have, downward you are taken as negative means upward is positive. So this is P is equal to, they have an initial velocity, right? They're given an initial velocity because you are throwing. Throwing means there will be velocity at initial stage. So 20 meter per second. So 20 t. That u, initial velocity, is also positive because it is in the positive direction. Okay. Plus half into minus 10. So look at this one. Here, this you need to take it as minus y because this is going upward, right? What is the acceleration? Acceleration is acceleration due to gravity. Gravity will always attract it towards its center, right? So g is negative. Downward you have taken as negative. Whether the ball is throwing upward or downward, the direction of gravity is always acting downward. Okay? So it is negative into t square. So what is the equation? Equation of SB will be equal to 20t minus 5t square. So this is the displacement expression. At any time, okay? After time t 10 seconds, you put 10, you will get the position of the particle. Okay, let's do the C part. Next is calculate the time at which the two stones meet. Okay, you need to find out the time at which two stones meet. C. Okay, you check that. Suppose these two stones are meeting at a point. Okay, so this will be what? SA in upward direction. This will be SB, right? So when you add both this displacement, what you should get? You should get the total height of the tower, right? So what is the total height of the tower given in the question? 80 meters. So if you are adding both SA plus SB, you should get what? 80. Right? So you can add SA plus SB. SA is 5t square plus SB is 20t minus 5t square equal to what? 80. Right? So 20t equal to 80. t is equal to 4 seconds. You got the answer, right? 4 seconds. It's easy. You need to remember we already substituted the negative sign. Okay, that is why you're getting the answer like this. The displacement of A plus displacement of B should be the total displacement 80, right? You understood? Next, determine the distance from the top of the tower at which the stone meets. So you need to find out the displacement. You got the time, right? 4 seconds. After 4 seconds, the stones are meeting. So that displacement you can substitute. So displacement for B, if you are substituting displacement for A, you substitute displacement for A. SA is equal to, that will be easy, right? 5t square. So 5 into 4 square. So 20 into 16 into 5, right? So 5 into 4 square, which is 16 into 5, 80 meters. So during this time, what happened? SA has, look at this displacement after 4 seconds, it has covered all the distance 80 meters. So from the top of the tower, 80 meters, right? They meet. What is the meaning? There, if you are throwing this up, it will come down. Both the stones will reach the ground at the same time. Okay, this will go up. What happens when you throw something upward? The speed reduces, become maximum 0, then it will come back, right? So during this time, during this 4 seconds, what happened? The stone B will reach maximum and it is coming back. Both stones will reach the ground at same time. I hope you understood the theory, how to solve equations of motion question, how to identify the equation, how to apply it in the question with the sign. Okay, sign is the, if you're taking upward positive, downward will be negative. Okay, you need to take all vector quantities, distance, displacement, velocity, acceleration, all are vector quantities. With a sign only you will substitute in the equation. Got it? Finished? Next. The last question. It's a theory question, I will explain it. A particle moves with a constant acceleration along a straight line. Okay. State the condition under which the equations of motions are valid. What are the conditions? It should be straight line motion and a constant acceleration. These points you need to remember. Okay, that's why I chose this question. Explain why this equation cannot be used if the acceleration varies with the time. Why? Because equations of motion is derived with an assumption that the acceleration is uniform. These equations are derived with the assumption that the acceleration is uniform. That means VT graph, if you draw, you are getting a straight line, right? Straight line graph only you will consider. If the graph is curved, you cannot apply this one. Understood? Second, give the one physical condition where the acceleration fails. Give one physical condition, so practical application where the equation can fail. Okay, so the condition you take for should be a straight line motion and constant acceleration. If the acceleration is constant, this will fail. If it is not a straight line, it will fail. So easiest example is what? Circular motion. Circular motion, the continuously the object is changing its direction. Changing its direction means it is not in a straight line motion, it is in a circular path. So circular motion will be the physical situation, and you can say a car is accelerated. It's not uniformly, right? Practically uniform acceleration is not there. It is not uniformly accelerated from 0 to 60 meter per second. The acceleration will be non-uniform only. So any two physical conditions you can take and write. Okay, I hope the theory and application of equation motion is clear to you. Do this question one more time. If you got anything wrong, do it again and understand what was the procedure. Okay, I will explain one more time the procedure, steps to do the equations of motion question. First one, you will identify which all values are given. So, and that time is there, or time is the requirement of the question. Then you need to go for first two equations. Check first two equations. B is equal to u plus at and s is equal to ut plus half at square. In the question, if displacement is requirement, then go for the second one. If velocity is the requirement, go for the first one. If in a question time is not at all required or the requirement is given, if the time is not given or not at all a requirement in the question, only one equation is there. V square is equal to u square plus 2s. Write the equation. If possible, draw the situation and check the direction. Okay, upward positive, downward negative, right positive, left negative. So you can choose that. Then put the equation, put the values with a sign. Then you will never lose mark from equations of motions. So the next video, module 2 kinematics, part 4C, where we will discuss theoretical MCQ questions. 5 questions we will discuss. Then after that we can start graphs and graph analysis. So that's it for today's video. See you in the next video with MCQs, theoretical MCQ practice. This is bye from Sanal. See you soon.